Thank you for being there for us. We still have this question to solve on Dalton's law of partial pressure. Now let's solve together. 300 cm cube of hydrogen, that's my V1, of hydrogen was collected over water at a temperature of 25 degrees Celsius. That's my T1 is equal to 25 degrees plus 273 to convert it to Kelvin, and that will give me 298 Kelvin. And pressure of this, since the gas is collected over water and this pressure now is not my P1, it's my total pressure because the gas is collected over water. Then I'll now write P total pressure equal to 101,325 Newton per meter square. What will be the volume of dry hydrogen at STP? That means V2 is question. Now since it has STP, my T2 will be equal to 273. Why my P2? Since my P2 now will be equal to, since I'm giving Newton per meter square, my T2 will be 101,325 Newton per meter square. Not this one, no. This one is the unit of Newton per meter square. If you don't understand how I got this one, you can check my previous video on STP, standard temperature and pressure. This 101,325 is not this one. This is standard pressure now. Then to get my P1, then recall from Dalton's law of partial pressure that PT, total pressure, is equal to pressure of dry gas, in this case hydrogen, plus partial pressure of water. If I substitute my value here now, my total pressure is this one. I have 101,325 is equal to partial pressure of oxygen that I'm looking for, of dry hydrogen now rather, then partial pressure of water. Water vapor pressure at 25 degrees Celsius is this. That's plus 1663. So in that case, my partial pressure of H2 now of dry hydrogen gas will be 101,325 minus 1663. So if I subtract this from this now, my partial pressure of dry hydrogen will now be equal to 101,325 minus 1663, and that will give me 99662 Newton per meter square. So this 99662 Newton per meter square will now serve as my P1. So my P1 is 99662 Newton per meter square. So anytime a gas is collected over water, that's one importance of Dalton's law of partial pressure, is for correction of gases that are collected over water. Then if I substitute all these my givens now to get my V2 in my general gas equation of P1 V1 over T1 is equal to P2 V2 over T2. So my P1 is now this one. So that's 99662 times V1 is this one. That's 300 over T1, which is this one now, 298, is equal to P2 is equal to this one, 101,325. V2 is what I'm looking for over T2, 273. If I first multiply this with times this, I will have 298 times 101,325 V2 is equal to 99662 times 300 times 273. If I multiply this by this now, I have 298 times 101,325. So that will give me 3019,4850 V2 is equal to this times this, 99662 times 300 times 273. So that will give me 8162317800. Divide both sides by the whole of this now to get my V2. So my V2 equal to 816231780 divided by 30194850. Then my V2 should be equal to this divided by this now. We have 30194850. And that will give me 270 centimeter cube. So my V2 is 270 centimeter cube. So this is another example of question on Dalton's law of partial pressure, and this is how you are expected to set the solution out. One more example is still coming on Dalton's law of partial pressure for better understanding. Stay tuned to Chemistry with Chris. Bye.